Good morning. Today I'd like to show you how to graph a dataset in Google Sheets, plot a trend line, and calculate an R-squared coefficient of correlation. First, we're going to open up a new Google Sheet. Let's title this one Video Tutorial. Good. Next, we need some data to graph. I collected some data earlier by measuring mass and volume of several pieces of silver. Let's select a column and title it Mass in grams. The next one will be volume in milliliters. And the last one will be density in grams per milliliter. Once you're satisfied with these, we're going to label this first column here piece number. Great. Now we're ready to enter our data pairs in the appropriate columns, like so. Good. From here, we can do a few things. So let's have the program calculate the density of each piece. First, select the first cell in the density column, type equals, then select the first mass value, type the backslash for divided by, and then select the first volume and hit enter. And it should display the density of that piece of silver. And it does, 10.49 grams per milliliter. I want to do this for all 10 pieces, and it's really easy. If you select the little solid square and drag it down, you will see the program automatically calculates all of those density values. Up next, we're going to calculate a few averages. So in cell A13, we're going to write the word sum. And in cell A14, we're going to write the word average. Select cell B13, which is the one I'm highlighted, and find the sigma symbol in the taskbar. It's one that looks like a backwards E. If you hover over it, it looks like functions, or it says functions. It may be hidden from you depending on your exact settings. If it is, try the More tab and it should be there. So if we select functions and then sum, and then if we highlight the data we want it to sum in orange and hit enter, the sum is displayed. Now let's calculate the average. So if we select the bottom cell here, B14, I'm going to do this the long way, hit equals, highlight the cell where I have the sum, and then backslash for divide, and then the number of data points we have, which is 10. And then enter. See, the average mass for our data pieces of silver here is 18.957 grams. Okay. Now we're going to get the average volume. I'm going to do this the short way, so just highlight the cell C14, and I'm going to click sigma again, and then average, and highlight my volume data, all 10 data points, and hit enter. 1.838 milliliters is my average volume. I'm going to do the same thing for density in cell D14. Average, highlight the data, and voila, our average density 10.2059, etc., etc. Excellent. So it looks like I measured very accurately. The average, or the density of silver is 10.48 grams per milliliter, so you can see my value is pretty close. Time to graph. Since I'm graphing density, I want mass on the y-axis and volume on the x. So I need to rearrange my data just a little bit. I'm going to highlight both columns of data, mass and volume, including the headings. I'm going to copy and paste them over here. Since the program will graph the first column on the x-axis and the second column on the y-axis, I need to flip these two. So I'm going to highlight my mass column, cut it, and paste it in H. There we go. Now we should be ready to graph. If I highlight the two data columns that I want to graph, columns G and H here, volume and mass, and then I select the figure that looks like a bar graph. If I hover over it, it says Insert Chart. Select that, and the chart editor shows up. We will be graphing scatter plots most of the time, which is this one in the bottom left. It looks like a bunch of dots on a graph. This type of graph shows patterns in data very well. So we're going to select it and then insert, and the graph appears. So select that, hit insert, and our graph appears. I like to put my graphs in their own sheet. So if I highlight this little arrow right here in the top right corner, click on it, say move to own sheet, and now I see a full page, full sheet picture of my graph. Let's rename this sheet. So I'm going to right click on the tab, select rename. We're going to title this Density of Silver Graph. We're going to do the same thing for our data, which is in sheet 1. So if we left click on it, we go back to our data. If we right click on it, we can rename. This is going to be Density of Silver Data. Okay, now I have my data on one sheet and my graph on the other. So let's take a look at our graph. First, let's look at the title. Let's rename it. Okay, the title now says mass versus volume and gives the units, which is exactly what this is. We graphed mass versus volume. Another term for mass versus or divided by volume is density. So let's click on the title and enter density of silver, and then our units, which will be grams per milliliter. Your title should be very descriptive and very specific. If we hit enter, and it applies the title. Next, let's pay attention to our axes. Both are labeled with the quantity and the units, so they don't need to change. We have mass in grams on the left, volume in milliliters on the x-axis. Both of these show the quantity that they are displaying and the units. We also pay attention to the labels here. Both of these, you'll notice, have 0 in the origin. And let's think about that for a second. Is 0, 0 a valid point for our graph? Would a piece of silver with a mass of 0 have a volume of 0? Yes, it would. This is good. If we needed to re-zero the axes, we could simply highlight one of the axes labels, click on it, and in the min or max, you can enter your data and set your range very easily. Since we just said 0, 0 would make a valid data point, let's add it to our graph. Click on the sheet with our data, and at the bottom of the data we graphed, over here, columns G and H, I'm simply going to enter my new data point, 0, 0. Go back to the graph and you should see a new point on your graph. And here it is, right in the origin. The program recognized that you wanted to add the point, so it graphs it for you. Awfully nice, don't you think? Next, we need to add a trend line, which is very, very simple. We're going to click on any data point, doesn't matter which one. We're going to click on the symbol that looks like a direct relationship, If you hover, it says trend line, none right now. We are going to find the drop down and we'll select linear. Always select linear. It will give you the most realistic relationship between your data points. So if we click linear, you should see a blue line appear. That is our trend line. If you select the line and click R squared, the correlation coefficient will be displayed in the legend. And there it is. R squared equals 0.992. This number tells us how closely the trend line matches all of our data points. 0.992 means that the line matches the data with 99.2% accuracy. Anything over 75% should be good for us most of the time. Professional scientists look for a number above 95%. Last thing, I want to know the slope of this line. Why, you ask? Because slope is calculated as rise, the change in y, over run, the change in x. In this graph, rise, the change in y, is change in mass, and run is change in x or change in volume. Mass divided by volume is another way of saying density. So the slope of this line should be fairly close to the density we calculated in our data before. If we click on the little eye symbol up here that says View Mode, it'll open up some new options for us. We've been in Edit mode so far. Let's go to View and see what it does. So, the most important thing it does is it allows us to view different points on our line. So if we hover over the line, you will see the equation of the trend line, y equals 10.662 times x minus 0.581, and then some bold numbers. Those bold numbers are the x and y coordinates of the point under your pointer. Okay? So you can slide along the line to see other points. What the program is doing here is called interpolating. It is calculating values that you did not measure that are based on your trend line. And these are internal to our data set. They are between the leftmost point and the rightmost point. Okay, the program will also extrapolate, which means it will calculate values that are outside the range of our measured data, like it's doing here at the right-hand side. So it's using the equation of the line to calculate new points. So from the slope of the line, we can tell that 10.662, our calculated average density was 10.21. Here it is. And the actual density of silver is 10.49. So I'd say we did pretty well. Congratulations. You've now just begun a new journey of effortless data analysis. We've just scratched the surface with Google Sheets, a fairly simple program. There are other more powerful programs out there like Excel or Logger Pro, but I'll leave those to another class time. Practice with this data set on your own. Sometime very soon I will ask you to do all of this with a new data set in class. May the force be with you.